Assalamu alaikum wa rahmatullah. Today we are going to look at a topic called work, energy, and power. But on this work, energy, and power, we are only going to treat a case of a work. Some students find it difficult to differentiate some formulas when they were asked to calculate a work. This work we are seeing categorized into three, that is based on the formula. On this work, the full meaning of a work, we already know what a word of work is, but we should have known that in physics. When we say a work, we mean an agent of a force moves in the direction of that force. That is a work. Now, for instance, we have known so many examples of a work. When you see somebody working, you can say, that guy is doing a work, or when somebody is cooking, like they say she is doing a work. When you see a laborers building a house, you can definitely say they are doing a work. But what matters in physics is two things. A force acts on that body or an object, and the distance covers on a work. That is why we arrange, or we know the total, or we can know the who works more than the other by a distance. Now, for instance, I ask a boy to lift a body, take it to 2 meters. It's different with a boy that take it to 10 meters. I know who work better than one another between them. That means work is determined based on the distance. Then we should take note of that. Then three formulas that I say on this work. Somebody will say, no, I only know the formula of the work first times. No. The first formula, everybody knows this formula that say work equals to force times distance. Everybody knows about this formula, which is normal, right from our secondary school levels. And this work, since we know correct, this is correct formula. Let me write it in full. Work equals to force times distance. Correct. We know this formula. This is formula number one. But from this formula, we derived and arrived another formula of a work. How? We know when we are dealing with the Earth, we have 9 planets. We know it right from our secondary school. I say it again, which is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But the world we are living in, we call it Earth. And that Earth, there is an agent called gravity of the Earth. With that gravity, that is what will make this Earth possible for us to live. Why? Because now, for instance, if I release this marker, it definitely goes down. What makes this marker to goes down is the gravity of the earth. It is at the surface of this earth. It is what makes things comes down. If now, for instance, let's take an example, saying a world. How can you imagine this world without the gravity of the earth? People will be swinging. That is why if you're watching such kind of movies, people's in the moon, the gravity in the moon is quite totally different with the gravity of the earth. It's minimal. Why it is minimal? Because that is why you can see those people in the moon moving freely under gravity, because the gravity is too minimal. But the gravity of the earth is up to 9.8 meter per second square, or 10 meter per second square. But at the meridian, at the equator, if this is Earth, some part of the world has 9.8 meter per second square, some part has 10 meter per second square. But at the meridian, that is at the equator, is even 9.7 meter per second square. Are you getting what I'm saying? So look at the value of gravity of the Earth within the Earth. That is what even makes things pull straight. That means some part of the world that moves in clockwise movement differs with the from part of the world that move anti-clockwise direction. You can only notify this when there is a funnel, you fill it with the water within this region. You will understand that when you wanted to flush the water, it moves in clockwise direction. In some part of the world, it moves anti-clockwise direction. But at the middle, that is at the meridian, at the equator, it moves straight. Those of you that went to Uganda, that is at the equator, at that position, they feel the practical of this gravity of the earth, that of this movement of the gravity of the earth. Fine. Since we know this gravity is important, that means whenever we wanted to lift a body, it's not possible for us to lift a body without the gravity. Why? Because the gravity of the earth is upholding the motion of that body we wanted to lift. That means our pulse will change to mass times acceleration due to gravity. Why does it change to acceleration due to gravity? We know the formula of force is mass times acceleration. But in this case, that acceleration will change to acceleration due to gravity. Likewise, for distance, our distance will change to a height because now we are lifting the body. No one says it is not a distance. Definitely, a walk will change to, if force is mg, that is mass times acceleration due to gravity, then we have mg of that force multiplied by a height, that is a h. Definitely, our work will be mgh. This is second formula. If you look at this formula is the same as the formula with the formula of potential energy. So our second formula is W equals to mgh. We have the second formula. Again, when we have the third formula, there's a formula that deals with the motion of an angle. When a post moves to the direction of an angle, then we have work will be equals to that force with that angle multiplied by a distance. These are the three formulas we have when we wanted to solve a work problem. That is, this is formula number 3. Formula number 1 in summary says work equals to force times distance. Formula number 2 says work equals to mgh, right? Formula number 3 says work equals to force. We can still say times distance cos theta. It's all the same. We only interchange the distance. So these are 3 formulas we can use whenever a work cases are given. We may use the first one or the second one or the third one. So a student should quickly think when a calculation is given. You were asked to calculate a work. You first think of the first formula. If it doesn't apply, think of the second formula. If it doesn't apply, try a third formula. I'm sure within these 3 formulas, you can be able to solve any work problem. Our next lesson is going to be based on how to calculate a work using the first formula or the second formula or the third formula. I would like to see your comment. You can drop out your comment. Don't forget to subscribe and share. Thank you.